The familiar, distant moon we gaze upon is a lie. For billions of years, our closest celestial neighbor was a terrifying, colossal presence, its immense gravity warping our entire planet. This film unearths the shocking truth about Earth's earliest days, when the moon was a monstrous, fiery orb. Scientific estimates place its initial orbit breathtakingly close, between a mere 22,540,000 kilometers from Earth's surface. At that distance, the infant moon was a molten furnace, a global magma ocean, staring down at a nascent Earth. Its gravitational grip, intensified by this embrace, exerted forces up to 5,000 times more powerful than the tides we know today. This was a relentless, crushing pressure, literally distorting Earth's own liquid body, twisting and stretching the very fabric of our nascent world. What was this early Earth truly like under such a celestial giant? How could it survive this overwhelming, colossal neighbor? To comprehend the unimaginable forces that shaped it, we must journey back to the cataclysm that forged this cosmic duet. To truly grasp those forces, we must rewind the clock approximately 4.5 billion years. This was the moment of violent genesis, when our moon was born in fire and fury, not as a distant, serene orb, but as a monstrous, intimate companion. Its terrifying proximity fundamentally reshaped our nascent planet. Imagine a world where days flashed by at unimaginable speed, where the very crust of the Earth was stretched and pulled, deformed by an invisible hand. This was no gentle formation. It was a cosmic forging, an era where constant, extreme gravitational exchanges dictated everything from planetary rotation to the churning of global oceans. The evidence of this unimaginable past is not lost to time. It is etched into Earth's deepest geological scars, in the fundamental rhythms of our planet, even in the very fabric of life itself. We are only now beginning to decode the secrets of this turbulent youth. But before we can fully understand its profound influence, we must first witness the extraordinary event that birthed our moon. And at that moment, approximately 4.5 billion years ago, Earth's destiny was violently forged in a cosmic catastrophe, a Mars-sized protoplanet named Theia slammed into the nascent proto-Earth. This was no glancing blow, but an impact of truly unimaginable scale, an event that tore both celestial bodies apart, pulverizing rock and metal alike. A colossal plume of superheated, vaporized material, millions of degrees hot, exploded outwards, scattering into a vast incandescent ring around our wounded planet. This fiery torrent of primordial debris, illuminated by the energies of its creation, stretched hundreds of thousands of kilometers across the primordial sky, a temporary nebula of destruction and promise. This wasn't merely a cataclysm. It was the single defining Genesis event that would fundamentally redefine our world forever. From this swirling, fiery ring, the raw building blocks of a new companion, born of both worlds, would slowly begin to gather. It coalesced into our nascent moon, which, as described earlier, was molten to its very core, crowned by a global magma ocean that glistened with primordial heat. This wasn't a serene, distant orb. but a luminous, fiery infant, radiating immense energy. Scientific estimates place its initial proximity at the breathtakingly close distance mentioned earlier, a mere fraction of its current distance. Its overwhelming presence in the nascent sky would have been a constant, incandescent beacon, dominating the heavens with fierce light. For roughly 100 million years, this close, fiery companion would slowly cool, its vast magma ocean solidifying into the lunar crust we know today. This intimate, terrifying embrace set the stage for an era of unprecedented gravitational interaction, profoundly shaping its planetary partner. But how, exactly, did Earth itself respond to this overwhelming, fiery neighbor? Earth's own primordial landscape was equally in flux, a seething cauldron. Its surface remained largely molten, a viscous, churning ocean of superheated rock and metal, ceaselessly churned by powerful internal forces. Volcanoes spewed incandescent lava across a global landscape, painting the entire planet in hues of furious orange and red. This was the Hadean Eon, a period not just of formation, but of ceaseless transformation, a raw, still-forming world bombarded by lingering debris. The new, molten moon did not just orbit. It was a vast, incandescent mirror, its magma ocean reflecting Earth's fiery chaos. Two worlds bound in a celestial duet of liquid rock. This violent partnership, intense and overwhelming, was not merely destructive. It was a forging crucible, an era of rapid planetary differentiation, where the very structure of our world was violently defined. This intimate gravitational embrace between two molten giants generated forces beyond our comprehension, forces that would profoundly distort Earth itself, physically pulling and stretching its still liquid body. The moon's incredible proximity meant its gravitational pull was immense, exerting titanic tidal forces on the molten Earth. This wasn't about ocean tides. Instead, it manifested as lava tides, literally distorting the liquid Earth. Its viscous, incandescent surface continuously bulged and stretched under the moon's relentless gravitational embrace, a constant flexing of the planet's entire body. Imagine vast, slow waves of liquid rock, powerfully deforming the proto-Earth, kneaded constantly by a cosmic hand. This profound physical warping had immediate, dramatic consequences, intensely churning Earth's internal layers and shaping its nascent core mantle boundaries, even as our world struggled to cool. These powerful lava tides did more than just distort. They initiated a crucial process: the moon's initial departure. As gravitational friction began to subtly push it outwards, this interaction accelerated its retreat from Earth far more rapidly over tens of thousands of years than at any later point in its history. A dynamic evolution beginning almost instantaneously. The notion of an instantaneous beginning extended to the moon itself. For a long time, scientists believed our moon slowly gathered, accreting from the colossal collisions scattered debris over months or even years. But new, advanced simulations now dramatically challenge this assumption. These models suggest a far more rapid genesis. The moon might have coalesced not gradually, but within a matter of mere hours following the Theia impact. This lightning-fast formation meant a fully formed, molten companion was thrust into Earth's terrifyingly close orbit almost instantly. There was no slow buildup, only an immediate, overwhelming gravitational presence. This speed amplifies the sheer violence and efficiency of the earthly solar system, leaving Earth to contend with a titanic celestial partner from the very moment of its birth. It was this immediate, intimate embrace that set the stage for profound, rapid changes on our nascent planet. The close gravitational interaction with the Moon had another profound effect. It drastically accelerated Earth's spin. When the Moon first formed, a day on Earth was estimated to be less than 10 hours long. Some simulations even suggest it could have been as brief as 4 to 5 hours. Imagine a world rotating with such furious momentum. The sun would have ripped across the sky in mere hours, followed by a fleeting night, only to rise again with dizzying speed. This rapid, relentless cycle of dawn and dusk defined the very cadence of primordial Earth, shaping its climate and atmospheric dynamics in ways we are only now beginning to grasp. It was a planet perpetually in motion, its rapid spin a direct consequence of the immense gravitational tango with its massive, close companion. What an utterly alien sky that must have been, rushing by with every hyper-fast rotation. That alien sky, perpetually rushing by, would have been utterly commanded by a colossal, molten orb. Imagine its scale, appearing not just larger, but an astonishing 3,000 to 5,000 times more expansive than our familiar Moon does today. This was a dynamic, active world, so close that its fiery glow would have painted the tumultuous, rapidly rotating Earth in an otherworldly, ceaselessly shifting light. Giant shadows would sweep across the primordial landscape with dizzying speed, a dizzying cosmic dance unfolding every few hours. This overwhelming celestial neighbor was a constant, terrifying spectacle, its immense gravitational embrace visibly pulling and distorting the viscous, molten surface of our planet. A visible precursor to the ceaseless, immense lava tides that churned the very foundation of early Earth. These immense lava tides, churning the very foundation of early Earth, were not merely a brutal spectacle. They were the primary engine for the Moon's initial departure. The relentless gravitational pulling and pushing on Earth's vast, molten body created a profound cosmic friction. This friction did not simply distort, it systematically transferred rotational energy from our rapidly spinning planet directly to the nascent Moon. It was a profound one-way exchange, essentially flinging the Moon outwards, causing it to spiral away from its terrifyingly close embrace. This interaction marked the fastest period of lunar recession in history. For tens of thousands of years, our colossal satellite accelerated its retreat from Earth at a speed it would never again achieve, a frantic escape from a world it helped churn. This was a crucial, violent dance of separation. But what would happen when this intensely heated, constantly warped Earth finally began its long, slow process of cooling? As Earth slowly began to cool over millions of years, its surface solidified, and vast oceans started to form, accumulating liquid water. This crucial transition marked a new phase in the Earth-Moon dynamic. The immense tidal forces, once acting on molten rock, now churned colossal bodies of water, ushering in an era of unimaginable oceanic upheaval that profoundly shaped the planet's nascent hydrological cycles. Imagine oceans not gently ebbing and flowing, but violently sloshing, driven by a lunar pull still many times more powerful than today. These primordial liquid masses were perpetually in motion, responding with brutal immediacy to the closed moon's relentless gravitational grasp. This constant, planetary-scale agitation dramatically mixed the young seas, sculpting shorelines and influencing the earliest deep currents. It was a world defined by liquid chaos, where the very chemistry of the oceans was relentlessly remade. With liquid water now accumulating, the moon's proximity meant tidal forces became the immense forces described earlier, now acting on liquid water rather than molten rock. This generated extreme high and low tides, reaching not just tens, but potentially hundreds of meters in height. Imagine the scale: entire coastlines, vast stretches of emerging land, weren't merely washed, but violently consumed and exposed, then consumed again, multiple times in a single short day. This was a global ebb and flow of titanic, destructive proportions, an almost constant, visceral assault of water on the planet's nascent crust. These primordial megatides would have reshaped shorelines with unimaginable speed, carving out immense basins and grinding down nascent geological features, a relentless cosmic churning that ensured no landmass remained untouched for long. This immense, continuous flex and strain was more than surface erosion. It was a fundamental stress on the very bedrock of Earth. This persistent gravitational assault wasn't just surface deep. It warped the planet's entire nascent crust. The moon's relentless pulling and pushing, the constant stretching and compressing, injected immense energy into Earth's liquid interior. This deep-seated planetary torment generated heat, likely intensifying Earth's already vigorous early volcanism. It could even have been a critical force, helping to initiate the very first slow rumblings of crustal plate movements, the fundamental architecture of our world still in its chaotic infancy. Thus, the moon was no mere celestial neighbor. It was an architect, its gravitational embrace fundamentally sculpting Earth's early dynamic geology. Such violent geological sculpting, driven by the close moon, ensured that any emerging landmasses would face an equally extreme, constantly shifting environment, a world where the boundary between exposed land and churned ocean redefined itself with dizzying speed. This relentless, violent sculpting extended its reach into the very air above. Such a hyper-dynamic land-water interface, coupled with an Earth spinning in mere hours, constantly warped early atmospheric conditions. The sheer speed of Earth's rotation, a dizzying cycle of only a few hours, amplified the Coriolis effect to an extreme. Air masses attempting to move across the planet would have been violently deflected, twisting into colossal, perpetual storm systems, a world where winds consistently approached hurricane scale. Massive amounts of moisture, relentlessly churned and evaporated from the titanic tides, would have boiled into the atmosphere, creating dense, rapidly forming and dissipating cloud banks that reformed with every fleeting sunrise and sunset. This extreme thermal cycling, driven by the rapid day-night shifts, fueled violent convection, generating powerful updrafts and downdrafts that carved through the turbulent air. The result was a furious planetary-scale weather system, a constant, churning maelstrom of moisture, air, and heat, profoundly shaped by the close moon's relentless gravitational pull. It was an atmospheric inferno, a direct daily manifestation of a cosmic power that truly filled the sky. Yet, even amidst this atmospheric inferno, the true spectacle lay above. The colossal orb described earlier, its incandescent surface, a roiling ocean of liquid rock, would have pulsed with an unearthly red and orange glow, bathing the primordial landscape in a light both terrifying and mesmerizing. This was a constant, active presence, its sheer scale overwhelming any nascent observer. The ceaseless churn of its fiery surface, visible to the naked eye, would have cast dynamic, ever-changing shadows, turning the rapid progression of Earth's day into a dizzying ballet of cosmic light and dark. It was a vision of profound, raw power, inspiring both primal awe and an inescapable dread of the forces that sculpted existence. But how do we truly know such a colossal, incandescent world once commanded our skies, leaving behind no direct witnesses? The answer to that profound question lies not in the stars we observe today, but in microscopic records preserved within ancient rock, deep beneath our feet. Scientists have painstakingly unearthed specific layered sedimentary structures, geological fingerprints from epochs long past, known as tidal rhythmites. These quiet witnesses act as ancient chronometers, holding the secrets to Earth's past rotation and the moon's changing distance. They are vast, layered libraries, silently chronicling the relentless cosmic dance between our planet and its colossal companion. Each stratum, each subtle shift in grain, carries information from a time when the Hadean sky was a crucible of fire and gravitational might. But what are these extraordinary formations? And how exactly do their ancient layers reveal such precise information about a world billions of years removed from our own? Tidal rhythmites are fossilized imprints of ancient ocean movements, built layer by precise layer. Tidal currents deposit sediments, creating distinct bands that chronicle the relentless ebb and flow of early Earth's waters. Each light and dark sediment pair, a daily couplet, marks a single solar day's tides. Thicker cycles reflect the monthly dance of spring and neap tides, driven by the moon's changing gravitational alignment, and annual stratifications tied to Earth's seasonal tilt, are etched into these geological archives. By meticulously measuring the thickness variations within these daily couplets, monthly patterns, and yearly bands, geologists unlock a trove of specific data. They precisely calculate the length of an ancient day, literally counting how many couplets defined a month, or how many days filled a primordial year. From these fundamental rhythms, crucially, they then infer the moon's exact orbital period and, thereby, its precise distance from Earth. At the very moment that sediment was laid down. This technique offers physical undeniable proof from billions of years ago, transforming abstract theory into a geological clock frozen in time. What startling secrets have these ancient chronometers already revealed about our planet's earliest days? From these ancient chronometers, scientists piece together startling revelations. One specific snapshot, preserved from roughly 9 billion years ago, indicates the moon orbited Earth at a distance of approximately 133,800 kilometers. Even at this point, millions of years after its chaotic birth, the moon still dominated the sky, appearing an astonishing 3 times larger than its familiar disk today. Imagine this colossal orb, a constant, luminous presence, casting immense light and shadow across a still-forming Earth. It was a spectacle of overwhelming power, a tangible answer to how close our celestial neighbor remained, still shaping Earth's landscape with relentless gravitational might. This evidence confirms the moon's initial, terrifying proximity and its subsequent gradual retreat. But this journey outwards, this cosmic separation, was not a simple, linear process. That cosmic separation, this journey outwards, was anything but linear. Geological evidence reveals the moon's retreat was significantly slower during the early Precambrian era than in subsequent periods. This suggests a profoundly different dynamic, a shifting tempo to the colossal forces at play between our two worlds. This inherent variability fundamentally complicates the grand narrative of our celestial partner, challenging any simple, predictable model of its departure. The Earth-Moon dance has been far more nuanced, a dynamic progression defying straightforward assumptions based on current observations alone. For scientists, this non-linearity is critical, revealing that calculating the moon's history requires more than a simple projection backward in time. It forces a crucial question. If the recession wasn't constant, then how can we truly reconstruct the moon's ancient past? Especially when popular assumptions about its steady, unchanging departure persist. The notion of a constant recession rate, however, quickly unravels. If the moon had always drifted away at today's measured 8 centimeters annually, the mathematics are clear. Rewind the clock, and you find the moon physically brushing Earth's surface a mere 5 to 1, 6 billion years ago. Think about that time frame. This isn't just a minor discrepancy, it's a catastrophic mismatch. Such a scenario would utterly invalidate every piece of geological and lunar evidence dating the moon's violent genesis to 5 billion years ago. That initial cataclysm, the very event that created our celestial companion, becomes impossible under this linear model. The simplistic idea of a steady, unchanging departure reveals itself as a profound oversimplification, one that dramatically distorts the true timeline of our planetary system. It forces us to confront a far more intricate cosmic ballet, where the forces governing the moon's retreat shifted dramatically over eons. This demands we abandon easy assumptions and seek out the real, nuanced story etched within Earth's ancient rocks, moving forward in time to uncover those crucial milestones. Building on that intricate ballet, further along Earth's timeline, ancient tidal rhythmites unveil another pivotal chapter. Roughly 46 billion years ago, these layered geological chronometers offer a precise reading. An Earth day then lasted approximately 17 hours. This marks a significant deceleration from the frenetic, ultra-short days of the Hadean Eon, confirming the Moon's ongoing influence in gradually breaking our planet's spin. Yet, even with this slowing, the same evidence reveals the Moon still held a considerably tighter orbit than it does today, its gravitational embrace far more potent than what we currently experience. This snapshot provides a crucial midpoint in the cosmic choreography, a measurable progression in the long drawn-out dance of recession. It paints a picture of a planet still profoundly shaped by its powerful celestial partner, its rhythms steadily moderating from primordial chaos. This precise data point, confirming a continuous lengthening of the day as the Moon receded, seemed to confirm a straightforward trajectory. But the deeper scientists looked, the more an unexpected stability emerged, challenging this very linearity and introducing a truly intriguing mystery. This unexpected stability reveals itself in perhaps one of the most intriguing mysteries in Earth's rotational history, the boring billion. For a vast stretch of time, from approximately 2 billion to 600 million years ago, Earth's day length remained surprisingly constant. A consistent 5 hours. This billion-year-long equilibrium profoundly challenges our understanding of the Moon's continuous influence. Standard physics dictated that lunar tidal braking should have steadily slowed Earth's spin, a predictable deceleration etched into the planet's very rhythm. Yet, for an extraordinary duration, a full billion years, Earth seemed to resist this relentless cosmic pull, holding its daily cycle in an almost unnerving stasis. What unseen force, what delicate cosmic counterbalance could have maintained such a precise equilibrium against the Moon's pervasive gravitational drag? The answer remained hidden, a profound anomaly in the planet's grand timeline, demanding explanation. The explanation for this profound anomaly in Earth's timeline, scientists discovered, lay not with the Moon alone, but in the subtle yet powerful influence of solar atmospheric tides. During this enigmatic era, the Sun's own gravitational pull created massive tidal bulges, not in Earth's oceans, but within its thick, evolving atmosphere. Under specific conditions, these immense atmospheric tides imparted a slight acceleration to Earth's rotation. This precisely counteracted the constant slowing effect of the lunar ocean tides. For a billion years, a delicate celestial tug-of-war played out, where the Sun and Moon, each with their distinct gravitational signature, locked Earth into an unexpected rotational equilibrium. This period of quiet stability was, in fact, the product of immense opposing energies. Yet, the persistent gravitational exchange between Earth and its companion would leave another, more permanent mark, subtly reshaping the Moon itself. That persistent gravitational exchange slowly sculpted the Moon itself. Earth's relentless pull acting unevenly on the Moon's still viscous interior and nascent crust, gradually distorted its companion. It became a subtle, elongated football shape, rather than a perfect sphere. This non-spherical distribution of mass meant Earth's gravity had more to grab on to at these bulges. Over eons, this constant tugging and pulling on those gravitational bulges slowed the Moon's rotation until it precisely matched its orbital period, a phenomenon we call tidal locking. This is why, without fail, we always see the same face of the Moon staring back at us. It's an enduring cosmic embrace, established billions of years ago, a permanent marker of the powerful, relentless forces that once raged between these two worlds. A silent, unchanging witness to Earth's tumultuous history, forever bound in this gravitational ballet. Yet, even this fixed gaze isn't static. The Moon's subtle influence on Earth continues its relentless work. Its gradual departure still an active process, albeit now at a far gentler pace than its chaotic beginnings. Today, the Moon continues its slow, majestic departure from Earth, drifting outward at an average rate of about 8 centimeters, 1.5 inches. Each year, this precise recession is meticulously tracked using lunar laser ranging, a remarkable technique that bounces powerful laser beams off specialized reflectors left on the lunar surface by the Apollo missions. These measurements, precise to the millimeter, offer unequivocal proof of the Moon's ongoing, yet subtle, retreat. This modern, almost imperceptible drift stands in stark contrast to its tumultuous early history, when immense gravitational forces propelled it away at a far swifter, less predictable velocity. This dramatic difference in recession rates across billions of years is not merely a detail. It's a critical clue to understanding the constantly evolving dynamics of the Earth-Moon system, definitively answering why its departure has never been a constant, linear process. For billions of years, the Moon's gradual recession brought a profound moderation to tidal forces, fundamentally redirecting global ocean currents. What were once overwhelming, destructive surges slowly transitioned into a more consistent, rhythmic propulsion. This persistent, yet gentler, gravitational tug orchestrated the vast planetary scale mixing of ocean waters, distributing vital heat from the equator towards the poles, preventing extreme thermal gradients. More crucially, this ceaseless circulation transported essential dissolved nutrients, metals, and organic compounds throughout the burgeoning, shallow seas and deeper abyssal zones. This dynamic exchange of energy and chemistry created diverse, stable environments, dictating precisely where and how early marine life could not only survive, but thrive, evolve, and diversify across Earth's vast aquatic realms. Such a foundational influence on oceanic health and biological distribution proved indispensable for the long-term regulation of Earth's entire climate system. This profound climate regulation unfolded through a complex interplay of forces. The evolving Earth-Moon system, with its dramatically changing day lengths and titanic tidal patterns, relentlessly influenced the distribution of solar energy across the planet. Imagine a planet spinning faster or slower, with immense bulges of water constantly shifting. This dynamic churn directly reshaped atmospheric circulation. It dictated how moisture evaporated, condensed, and was transported globally, creating weather systems fundamentally different from our own. Over billions of years, this celestial choreography steered global climate patterns, transitioning Earth from a chaotic furnace to a world capable of fostering stable, predictable conditions. Conditions critical for complex ecosystems to not just emerge, but truly persist and flourish across vast continents and deep oceans. Yet, even as this grand climate system stabilized, the memory of those extreme tides lingered, shaping specific environments in ways we are only now beginning to grasp. Among these unique environments were the dynamic tidal pools along nascent coastlines. Here, the planet's colossal, ancient tides created cycles of wetting and drying unlike any seen today. With the moon so close, these immense daily ebbs and flows meant coastal regions were regularly flooded, then exposed. As water receded, the dissolved organic molecules within these pools would have concentrated dramatically, effectively trapping them together. This repeated process of concentration and dehydration provided the precise energy input and density needed for these simple chemical precursors to react. They would link, break apart, and reform, gradually polymerizing into more complex chains, the vital building blocks of proteins and nucleic acids. Such conditions, specifically the rhythm of extreme tidal exposure, are now hypothesized as a crucial mechanism for abogenesis. Without this colossal, relentless lunar influence, driving those specific chemical reactions, the very spark of life on Earth might have been extinguished before it even began. The moon's immense gravitational pull, therefore, didn't just sculpt geology and climate. It catalyzed the very genesis of life itself, profoundly influencing Earth's biological destiny. This was a force that literally laid the essential chemical groundwork for Anduin for everything that followed. Beyond nurturing life's earliest chemistry, the moon's intricate orbital dynamics provided something more. A grand cosmic clock for Earth itself, its evolving distance and relentless gravitational pull influenced, and indeed recorded, the rhythmic layering of sediments. These geological markers, far more than just snapshots of ancient tides, became invaluable chronometers. Tidal rhythmites, through their detailed patterns, provided precise dates and calibration points across billions of years. Scientists could use them to not only trace the moon's retreat, but to establish exact timelines for critical transitions within Earth's deep history, meticulously mapping the grand chronology of its geological periods. They offered an unparalleled ability to correlate events, to understand the true immense timescales involved in planetary evolution, and to reveal how our world gradually stabilized. This silent planetary rhythm, etched into stone over eons, profoundly shaped Earth's very timeline. Yet, how might such a colossal, ever-present celestial arbiter have appeared to any nascent intelligence emerging on a planet so utterly transformed. To any nascent intelligence, emerging on a planet so utterly transformed, that colossal orb would have been fundamentally alien to comprehension. Its sheer, overwhelming scale, appearing like a world unto itself, would have dwarfed everything known, distorting perceptions of heaven and earth. This was no serene companion. Was a dynamic, living presence that filled the entire sky, moving visibly across the firmament multiple times a day. Such an ever-present, terrifying entity would embed a primal sense of awe and terror deep into any emerging consciousness. It would dominate early fears, inspire vivid mythologies of celestial giants and cosmic creators, and shape the very interpretation of existence itself. Its cycles, the immense power it wielded, would be central to creation stories and the understanding of universal forces. Its echoes, though now softened by billions of years of retreat, still resonate within the subtle forces that guide our planet's stability today. Those echoes, though softened by billions of years, still resonate. Even today, the moon's subtle gravitational presence remains an omnipresent force. Beyond the dramatic tides it raises, its persistent pull profoundly influences Earth's rotation, helping to maintain crucial environmental stability. This constant, gentle tug continues to regulate our planet's fundamental processes, ensuring a pace of spin that contributes to stable, predictable climate patterns. By subtly influencing the distribution of solar energy across the globe, orchestrating atmospheric circulation, and guiding the transport of moisture, the moon acts as a silent architect. It sculpts the very conditions necessary for complex ecosystems to emerge and persist, providing a long-term predictability that underpins the evolution of life. Its enduring impact extends far beyond its ancient, more volatile beginnings into the steady rhythm of our world, this grand cosmic ballet. Initiated by a colossal impact billions of years ago, is not yet over. This same mechanism, the fundamental conservation of angular momentum, continues to dictate the dance. Earth's relentless gravitational tug creates subtle tidal bulges, not just in oceans but in its solid body, ever so slightly distorting our planet. As Earth spins beneath them, these bulges are pulled slightly ahead of the moon. This misalignment creates a constant gravitational drag, a gentle yet inexorable cosmic break. This friction siphons rotational energy from Earth, minutely lengthening our days, second by second, century by century. That energy doesn't vanish. Instead, it transfers to the moon, subtly boosting its orbital speed and pushing it incrementally further away from us. This ongoing exchange, a continuous rebalancing of kinetic and gravitational forces, defines our system's mechanics, a process set in motion billions of years ago, and one that continues without end. But what does this slow, deliberate drift, spanning eons, truly mean for Earth's far future? This ongoing drift, stretching into cosmic time, hints at a profound future for our world. If the moon continues its slow departure indefinitely, its gravitational influence will wane, causing Earth's rotation to slow even further. Eventually, the colossal tidal forces that once sculpted oceans and reshaped landmasses would diminish to a mere whisper. This drastic reduction of tidal energy could unravel the delicate balance of ocean ecosystems, altering nutrient circulation and the very marine life that evolved within these rhythms. More critically, the Moon's stabilizing gravitational presence currently dampens Earth's axial wobble, preserving a relatively stable climate over eons. Without this lunar anchor, our planet's tilt could become far more erratic, potentially plunging vast regions into cycles of extreme seasons or prolonged ice ages. Such a future illustrates the relentless, irreversible nature of cosmic evolution, where stability itself is a temporary state. But before contemplating its distant exit, we must understand how its presence, billions of years ago, was essential to solidify our world. Its early, powerful gravitational grasp had constantly distorted our planet's molten surface, generating immense internal friction deep within its interior. This relentless tugging, a cosmic kneading, kept Earth's primal crust thin, fractured, and perpetually unstable. But as the Moon slowly retreated, those crushing forces lessened. The immense tidal stress, which once prevented any lasting surface stability, began to ease. This gradual reduction in gravitational torment allowed Earth's still liquid interior to cool more efficiently, dampening the ceaseless internal churn that had defined its Hadean existence. Over vast timescales, this enabled the planet's evolving crust to solidify and thicken, eventually forming the very first stable land masses, the embryonic continents. Without this critical process, driven by the Moon's patient, billions of years-long withdrawal, the diverse, resilient geological structures that define our planet today, including the continents themselves, might never have found their foundational stability. This delicate, shifting gravitational balance was not merely about creating surface features. It was inextricably woven into the deeper rhythms and major transitions of Earth's geological evolution. The Moon's relentless pull, evolving from its earliest molten embrace to titanic ocean surges, continuously dictated patterns of sedimentation. Vast quantities of eroded material were transported and deposited in rhythmic layers, each marking the colossal daily and monthly cycles of a closer moon. These powerful forces also fueled immense erosion, sculpting primeval landmasses and reshaping coastal zones with an intensity unimaginable today. Over billions of years, this dynamic lunar influence forged the very stratification of Earth's crust, writing its history into rock layers, marking epochs by the evolving celestial mechanics. Our planet was not merely a passive recipient. It was an active participant in this cosmic dance, constantly reformed by a force that both threatened and shaped its very existence. The true enigma, then, is not just what happened, but how Earth could endure such a profound, continuous metamorphosis. The truth is, Earth did not merely endure. It was radically forged, every violent tremor and titanic tide shaping the very architecture of its existence. The Moon's relentless, overwhelming presence provided the engine for a deep-time acceleration, driving planetary processes that would otherwise have taken far longer to manifest. These immense forces, acting on a molten world, organized its planetary layers with brutal efficiency, establishing the stable, differentiated interior crucial for the sustained geological activity that defines our living planet. This constant, gravitational kneading generated incredible internal friction, supercharging the planet's own thermal engine and accelerating the separation of its dense metallic core from its lighter silicate mantle. Without such aggressive, primordial stirring, Earth's fundamental structure, and therefore its long-term geological dynamism, might have remained arrested in a far more homogeneous state. Simultaneously, the persistent stretching and compressing forces mechanically stressed the planet's embryonic crust, initiating the fracturing that would create the initial templates for the landmasses and basins that would eventually cradle the first oceans. This was the violent genesis not just of a planet, but of a world uniquely primed for life, its very foundations hammered into place by a celestial architect. The hidden history of our Earth-Moon system, spanning billions of years, is revealed not by speculation, but by the quiet witnesses embedded within rock itself. Tidal rhythmites. These ancient sedimentary layers, meticulously studied by generations of scientists, unlock the profound, precise secrets of Earth's changing rotation and the Moon's dynamic, winding journey through deep time. They are a physical archive, tangible and irrefutable, allowing us to reconstruct specific, vivid moments from billions of years removed from our present reality. Each fossilized ripple, each microscopic layer of sediment, captures the direct imprint of colossal forces that once shaped our planet. They offer an unprecedented, high-resolution view into the primordial mechanics of our world. Not merely telling us what happened, but precisely how and when, providing the bedrock for our understanding of the Earth-Moon system's epic evolution. This silent, granular record provides a continuous thread back through the Hadean and Archean eons, enabling us to piece together the planet's biography with astounding clarity. Beyond this silent, granular record, the Moon emerges as something far more than a passive companion. Its gravity, the very force that birthed colossal tides and spun Earth into a blur, also acted as an invisible, vital hand, steadily guiding the rhythms of our planet's existence. Crucially, this immense lunar pull helped stabilize Earth's axial tilt. Without its constant influence, our planet's angle of rotation would have likely wobbled chaotically, subjecting the world to extreme and unpredictable climate swings over vast geological timescales. Such dramatic instability could have prevented the consistent environmental conditions vital for complex life to not only emerge, but to evolve and endure. The Moon, in essence, provided the long-term climate equilibrium that nurtured a habitable world. It sculpted not just the planet's surface, but its very capacity for biological complexity, becoming an indispensable partner in Earth's cosmic journey. This cosmic partnership, now fully revealed, offers a mind-bending perspective shift. The familiar, serene orb we gaze upon tonight, that calm companion in the velvet sky, holds a hidden, violent history. Its placid modern face utterly belies a primordial power that once carved and contoured Earth itself with overwhelming gravitational might. Picture a world where the night sky wasn't a gentle expanse, but an active, volatile presence. A place where our planet was not merely impacted, but fundamentally rebuilt from the ground up. The sheer scale of its ancient influence is almost beyond our grasp, demonstrating a creation far more chaotic than commonly conceived. The very stability we now enjoy, the precise rhythm of our planet, was forged in that terrifying, close embrace hammered into existence by celestial mechanics. Its monumental force was not just a backdrop to Earth's formation. It was the dynamic engine that created the blueprint for life, a profound example of immense, ongoing astronomical processes that eternally sculpt our universe, even today. That monumental force, far from being just a destructive agent, evolved into the silent architect of Earth's destiny. Its persistent presence, even as it gradually receded, was the foundational assurance for our planet's long-term environmental and geological stability. The moon's tireless gravitational pull didn't just sculpt primordial coastlines, it perpetually churned nascent oceans, and, as we saw earlier, created dynamic intertidal zones. The perfect crucible for the earliest complex organic chemistry and the very genesis of life. This steady hand guided Earth from a chaotic, inhospitable realm into a world capable of sustaining rich ecosystems. Without that colossal, evolving presence in the sky, the trajectory of our blue planet, and the eventual emergence of humanity itself would be profoundly different. It was an indispensable partner in the cosmic ballet, transitioning Earth into the vibrant, living world we inhabit today. The indispensable partner that forged our vibrant, living world still dictates its very pulse. The tides we witness today, though powerful in their own right, are merely faint whispers of the moon's ancient roar. They are a diluted echo, a mere fraction of the titanic forces that once scoured continents and distorted a molten planet. Yet, even in this reduced form, the moon's relentless gravitational embrace continues to sculpt our environment. Its pull drives the vast ocean currents, regulating global heat distribution. It stabilizes our planet's axial tilt, preventing chaotic climate swings that could extinguish complex life. And it perpetually, subtly, breaks our spin, defining the very length of our days. This continuous, quiet dance, a legacy billions of years in the making, still underpins the delicate stability essential for our existence. Yet, the true paradox of our moon belongs to that ancient, turbulent past, a time when its overwhelming celestial presence did more than merely influence Earth. Its raw energies, once seeming purely destructive, were in fact the very engines of a grand planetary evolution, meticulously preparing the ultimate crucible for life. In its monstrous, incandescent glory, the moon acted simultaneously as a relentless sculptor and an indispensable guardian. It raged, tearing at the nascent crust, forcing rapid differentiation, and in that violent shaping, It forged the essential architecture of our world. A cosmic ballet where unimaginable power, both terrifying and mesmerizing, transformed primeval chaos into a planet not just capable of enduring, but of cradling complex existence. This duality, a terrifying beauty that enabled life, defines its enduring, profound role in Earth's epic saga. This cosmic relationship now provides a crucial lens through which to decode how such gravitational forces, orbital dynamics, and proximity could orchestrate a planet's climate, geology, and even the very emergence of life elsewhere. It transforms every distant orb into a potential silent architect, urging us to look beyond the surface to the deep gravitational dance that defines cosmic destinies.